My name is Pawel. I work for Nine as a platform engineer, and I will try to give you a brief introduction to the vCluster topic, which stands for virtual cluster. In short, what is it? It is a virtual cluster, and the main concepts are that it contains only, as you imagine, it's a lightweight version of cluster, and it contains only some Kubernetes components like API server, controller manager, storage backend. But the difference is that the default one is SQLite, and optionally you can have a scheduler for this. And vCluster builds by default on K3s, which is like a Kubernetes K8s is like a 10 letters, K3s is 5 letters, so it's like a half the size of the Kubernetes. So it's lightweight version, but also the newest version of vCluster supports other Kubernetes distribution like Xeros or even vanilla Kubernetes. And by default, vCluster runs this interesting concept. No worries, I have like a slide where I will show you. I will show you like what does architecture looks like. It's quite simple, but we need those concepts first to understand everything. So vCluster runs as a single pod, just one pod. That consists of 2 containers, control plane and syncer. I will explain that later on, but just a single pod running on a host cluster. And vCluster runs on top of another Kubernetes cluster. This is really important. That's not standalone concept. It needs some Kubernetes to run on, but it runs on a single pod. And vCluster runs as a regular stateful set inside a namespace of that host cluster, and that's simple as that. And everything that you create inside virtual cluster lives either on virtual cluster inside that pod, or is mirrored or synchronized into the real Kubernetes cluster. So after this introduction, just a quick visual representation of it. So we have at the bottom host cluster and vCluster at the top. And you see that we on the vCluster we can create namespaces, namespace 1 and 2, and we can have some pods and services inside vCluster, and that's our virtual cluster. And but under the hood, everything that has been created on the virtual cluster, syncer takes all that stuff and translates that stuff into the host cluster. So the real version of cluster is that we have those pods, and you see those longer names. Those are unique names for the pods. We have pod 1 on namespace 1, service A on namespace 1, etc. And everything runs on the host cluster. So you define something on vCluster, syncer makes sure that everything will be rewritten, and syncer puts everything into the host cluster. And as you see, we have only one namespace on the host cluster, but and everything has a unique name, pod. But in the vCluster we can have multiple namespaces. And why? What's the benefit of it? We run everything on the host cluster, so we have like a regular networking. So we reuse the resource we have right now. So vCluster is only the concept, and we use the real power of the host cluster. So the vCluster is as fast as the host cluster itself. That was the simple architecture concept for pods and services only. And we have also storage. So we have persistent volume climbs, the same situation. Whenever, whatever you create on the vCluster, syncer takes that and puts it to the host cluster. And then we have this connection to persistent volume. So as you can see, virtual cluster is only virtual, and everything we create on the virtual cluster can be synced back to the host cluster. Not everything, but the only the things we need, and more details about it right now. So whenever you start a virtual pod in a virtual cluster, Syncer takes that pod, and we have some rewrite situation, and Syncer starts that pod into this one namespace. Take a note that we have only one namespace for this, and virtual cluster can have multiple namespace. And Syncer starts this pod on this namespace on the host clusters. Okay, the same is for services and endpoints. So everything is synced back to the host cluster. The virtual cluster and the host cluster share the same service cluster IPs. Persistent volume climbs, you saw that situation as well. We have the syncing situation, we create persistent volume claims, and we sync back to the real persistent volume to the host cluster. And interesting thing about the configuration, config maps and secrets, because we have two scenarios here. Those secrets, if they are mounted to pods, those secrets will be synced to the host cluster, and all other config maps or secret will fully stay in the virtual cluster. That's really important information for platform engineers, because you can easily, I mean, in terms of security, you should know about this situation, that there are some resources that are being synced, and there are some resources that are purely in virtual cluster, and you as a host cluster do not have access to that space. But deployments, stateful CRDs, service accounts, are not synced. So everything stays purely in virtual cluster, and host cluster doesn't see anything from it. And I provided here like a link for all the resources, and there's like in the documentation there's a brief explanation like what resource is being synced back to the host cluster. So that's for the further reading. And what are design principles for the vCluster? The first one is it should be as lightweight as possible, because we run this vCluster on a single pod. And as you expect, we can have multiple vClusters running on a host cluster. So we can multiply vClusters as we like. It should be lightweight. And this is mainly achieved by using this K3S distribution as a control plane, a lightweight version, but 100% compatible with Kubernetes, the full Kubernetes version. We have no performance degradation, because our workloads running inside the vCluster or nested clusters, because we can nest later about the situation in different slides. We can run those vClusters. All the workloads is being synced to the host cluster, and as you can see, the real power comes from the host cluster. So you define the pod in vCluster, but everything, like we take resources for the host cluster. So we have no performance degradation. We just do the translation, and then the host cluster takes the heavy load and all the connection between pods and other workloads. Another benefit of virtual cluster is that it highly reduces the number of requests to the Kubernetes, which is like a real host cluster server, by ensuring that all those high-level resources, it's I didn't explain that earlier, but those are all those resources like deployments that stay purely inside vCluster. So all those requests going to those resources, deployments, stateful cells, CRDs, etc., are handled by the virtual cluster. So we redirect that traffic from the host cluster. And the last and really important thing is also that everything should be flexible and very easy to provisioning and clean up. And we have multiple tools to interact with vClusters. Virtual Cluster provides its own CLI tool to just with one command to create cluster or destroy cluster or whatever. We have Helm charts, we have kubectl, and we also have our own tool, nctl, that we use for other services we provide. And this tool is also like one command, and you have like vCluster in less than 2 minutes. So that's super nice, and you can clean up and destroy the whole cluster pretty much in an instant. And some interesting facts about vCluster. I mentioned that situation that we can have like a nesting tree, like vCluster living inside vCluster, living inside vCluster, etc. We provide, as a 9, we provide a managed version of vCluster. So, but in your local environment, local home environment, you can, or any other testing environment, you can go wild and try to nest vCluster inside vCluster and inside vCluster. Maybe there's some limit, I don't know, about the namespaces, because going back here, you see that Syncer creates those longer names for all the pods. And maybe there's a limitation because of the name of those pods. I don't know. Maybe there is another limitation, but you can go wild. You cannot do this in our version of the cluster managed version, because we do not provide that option. But you can go for the testing, and you can go wild and test that situation. But of course, it's not only for fun. Sometimes it is really useful to have that nested vClusters, because you can have like a multiple teams in your organization, and you can provide a different environment for each team. So you can nest those clusters, and here I am referencing a cool blog post about it, how you can benefit from nested vClusters. Another quite, I mean, it's not that big thing, but it's kind of I don't know, annoyed for someone. Maybe if you used to work with kubectl a lot, you are used to this. Whenever you ask for the list of resources, you have a list of the resources sorted by the name, and vCluster provides you list sorted by the age of the resources. And of course, you can live with this because you have kubectl, and then you can sort those resources, whatever. But sometimes there are third-party tools, like, I don't know, Visual Studio, for example. And if you have like hundreds of CRDs, for example, and then you have like a total mixture of everything, then you are basically screwed. But the simple explanation for this is that we are using K3s. K3s distribution uses Kine, which is like a etcd shim that translates the storage. As I mentioned, we have multiple storage possibilities. Like by default, it is SQL-like. And it seems that's the quote from the one of the thread on the GitHub issues, that maintainer response was that Kine is not sorting the keys in the name as etcd does, and he mentioned that it's not guaranteed anywhere, and it's kind of true, but I found out that there's a cool talk and this on the hunt of the etcd data inconsistencies from Marek Sierkowicz from Google, which is like one of maintainer of etcd, and he took that project and he started with also, I provide the link for this, the implicit Kubernetes etcd contract. They started with the official documentations, like a draft, like how, because there's a lot of unwritten rules, like how etcd should work, but no one wrote it down. And they started with this etcd contract documentation. And this is still draft. This is not official document, but the document says that objects listed in response must be in lexical order by their name. So maybe it will change. That's just a side note. I mean, it's not a big deal, but just to explanation, like why is it like it is. And by the way, I highly recommend this KubeCon talk by Marek Sierkowicz. Is like great talk about etcd and talk how you test the etcd, which is like a distributed database, how you test consistency. So a lot of cool ideas, and yeah, nice talk. And some tips, which is those tips comes from our own experience working with vCluster, preparing the managed version of vCluster. As I mentioned, optionally, that's not by default. You can have like a vCluster scheduler for, you can enable that. And we found out that we need to disable that because it breaks auto-scaling for us. And of course, there are a few trade-offs. We will benefit from the vCluster scheduler, but we came up with we decided to disable it because auto-scaling is way more important to have that also for our vClusters clusters. Also we find out that some of our end-to-end tests, we switched at some point to the vCluster, and we found out that vCluster is too fast, and then some our end-to-end test breaks, the situation breaks some things, and we had some issues that yeah, it worked previously because we used a different way of creation cluster, but vCluster is so fast that we discovered a few bugs, so we had to check and wait for some things. Yeah, so that's maybe also your case, so it's worth sharing. Also, it is really important also for platform engineers that if you build vCluster on top of your host cluster, and that's production and a ton of important stuff. So vCluster resources live with your normal infrastructure. So this sync situation, you should be very careful what you are syncing and maybe check everything, because you can easily share too much. I mean, to secrets or config maps, and you should take this into account, because yeah, some things are done automatically and it works, but it's not secure if you miss that. But there are a ton of benefits from having a vCluster. Of course, first one is the full admin access. You create the vCluster, and you have full. The host cluster has a lot of limitation. You can have like a few permissions, but whenever you have vCluster, you are admin, and you can deploy anything you want. So deploy CRDs, create namespaces, and paint and label nodes as you like. So you can experiment and test a lot of stuff. So that's really important. Of course, there are huge cost savings. This is like a light version of vCluster. So you run this on the host cluster, you consume less resources, and like spawning new vCluster is cheap, deleting them is cheap. So that's a nice thing. Low overhead. It's lightweight. K3s, as I mentioned, it's like a half of the size of Kubernetes. And control plane inside one single pod. That is amazing concept and brilliant idea. We have no network degradation because once more, whenever you create pod is synced back to the host cluster, and we have regular networking. So no, you have everything. You take everything from the host cluster, so you have the full potential of your host cluster. That's also important. API server, you have, as I mentioned, K3s server ensures 100% of full Kubernetes API server, so you can test everything. And security. Also, I mentioned that those users on the host cluster need much fewer permissions in the underlying host cluster. The administrator can give you just a few permissions. Then you create vCluster, and then you can go wild because you are admin, and you can test everything there. You do not need those permissions to the host cluster, and there's no chance you will break something. So really important thing as well. And also, you may ask, probably you use those tools like Kind, K3D, or Minikube on your local machines, and it seems that it is more a better solution for you, but it consumes way more resources on your machines, and then vCluster is way better optimized for all of this. So having I am referencing here a cool article about it as well. So yeah, you can compare the situation. How does it look like in the real life? And what are the use cases? Because of course, virtual cluster is not for everything. So we highly recommend the virtual cluster for dev environments, for local or remote development. For end-to-end tests, I mentioned our situation. We have a ton of end-to-end tests, and we use vCluster pretty in some of those end-to-end tests. You can test your stuff against multiple versions of Kubernetes, because it's really easy to create this cluster. It's really easy to destroy that cluster. So you can run multiple versions with multiple versions of Kubernetes, and that's super useful, I think. You can have virtual cluster for training workshops or as a demo cluster, because it's almost the same as full Kubernetes cluster. You can have like a real multi-tenancy. It's like also reference to the blog post that in Kubernetes you can have namespaces, of course, but that's not good enough for every situation. I mentioned that as a full admin you can create CRDs, you can create namespaces, and etc. So this is a way more possibilities that just a namespace tenancy. And again, like certain resources live globally in the cluster, so having only namespaces and that kind of concept of tenancy is not enough. You need a better way of isolation. So that is why we have vCluster, and again, another blog post about it. And quick comparison, because we as a 9 offer vCluster, like a managed version of vCluster, but of course nothing. You can create vCluster very easily in your environment. We just provide this managed version, and we also have our 9 Kubernetes engine, which is also like a managed version of a full Kubernetes cluster. And what are the similarities? As you can see, we have service type load balancers for both. We have persistent storage for both. We can have ingress for both, auto scaling, but take a note that this scheduling, this extra scheduler will break that, but yeah, maybe it will be fixed in the future. Argo CD integration. You can have like a machine types for your vCluster, so you can use also machine types because under the hood you are still using the host cluster, so you can have the potential of the host cluster itself, and dedicated worker nodes. But what are the differences? There is no HI control plane, dedicated HI control plane nodes. You cannot have cluster add-ons, which is like we provide a ton of extra features, which you can simply enable in our managed version of NKE, but it is not possible to provide all of this to the vCluster itself. You do not have automatic backups for this. You do not have uptime guarantees for this, but you also do not need to pay cluster fee, and you have fast creation time, and you can be cluster admin. I mean, managed version of our Kubernetes, we cannot provide that for you because that's the managed version. So you see that there are a lot of benefits for this in certain environments, and but you need to pay for this. Because some features are not available for vCluster. It's not like a magic solution, magic tool, but it simplifies a lot of things. I mean, it's cost effective, and it's fast. So in development environments, it's a super nice solution. And also we offer, we have our product deployer, and sometimes people ask us like, is it the same as vCluster, or what is it? So just in short, those are completely different products. So deployer is like a managed platform when we just bring your source code and we deploy that on Kubernetes. And vCluster is like a lightweight version of Kubernetes cluster. So both products, the common factor is that both products run on the host cluster. So at the end of the day, deployer, whatever we take from your Git repository and we deploy that, it runs on our NKE infrastructure, and the same vCluster. vCluster is just a tool running on our infrastructure. So both run on NKE, on our managed version of Kubernetes, but those are completely different tools. So just to explain that. And last thing is a bunch of resources, like where to start. So we highly recommend our documentation, which is like a really brief introduction into the topic, really simple with getting started guide, etc. 9 blog posts. Also quick introduction to the Kubernetes cluster with more details and more links to the resources. We highly recommend our, if you will play with our infrastructure, our NCTL tool, which is like a universal tool for our 9 products. NCTL also supports vCluster, just one line, and then you create cluster and you destroy cluster as you like. And there's a ton of articles about vClusters and of course GitHub and official GitHub and documentation of vCluster. A ton of useful information. Those projects are really active, and we highly recommend to follow that, to experiment with this on your local environment. This is a really cool concept, and if someone is interested in taking deep dive into this vCluster topic, is quite it's a quite nice tool and a ton of good architecture solutions. So we highly recommend that. Yeah, so that's it. If you have any questions, I am here to ask those.
a small one.
Yeah.
But I mean, you kind of answered it already, right? But did you see that there's is there like a limit between version shifts, right? Because you can have different version for your vCluster and your host, but is there, or did you experience that there's like a limit on, how many versions do they guarantee to be compatible?
I mean, we kind of limit that. I mean, the recommendation from Kubernetes is that you cannot upgrade one version, more than one version at once. Yeah, and we kind of control that. We added that recently, that we check the version, and you can upgrade, but no more than one version, and you cannot downgrade. We kind of follow the same situation because vCluster uses K3s project, and K3s is a separate thing. You can easily create that Kubernetes cluster using K3s and run it, and vCluster just uses those versions of K3s, and I mean that's the rule. I mean, probably anyone follows that rule, that just upgrade one version of Kubernetes, no more. But you can try. I mean, that's a local test the environment. So this is also really useful whenever you like to try whether or not your application is bulletproof. You can just create like another cluster, because probably there is no point. I don't know. Maybe you have a ton of stuff on your vCluster, but for some scenarios, it is useful just to create another vCluster because it is cheap and fast with another version, and test your stuff there. But also, like, upgrading the cluster also works. One question, yeah.
Yeah, the vCluster control plane is just one pod, but is it single point of failure or is it some stateful application?
Yeah, it's single point of failure. So yeah, we cannot guarantee. I mean, there are some recommendation, and you can read some blog posts about having HA situation for this, but we do not provide that. We cannot guarantee that it will work. So you should take this also into account. That's not for production. We do not recommend that for production. Yeah. More questions? No. So okay. Thank you very much.